Section 22.3 Electron Counting and Oxidation States. There are two ways to count the number of valence electrons that surround the transition metal center. The first method is neutral ligand method. When you use this method, you should always treat each ligand as a neutral ligand with a zero charge. This is okay if you actually have a neutral ligand, such as aqua, amine, carbonyl ligands. So this is fine. But if you have a negatively charged ligand, such as chloride, well, in this case, you can still count the number of valence electrons correctly, but it has just no physical meaning. It's illogical. So I would say this neutral ligand method should never be used. But still, I want to give you the example. Given this transition metal complex, this platinum has 10 valence electrons, and each chlorine is treated as a neutral radical. So each may contribute only one valence electron to the metal. So you have 10 electrons from platinum, 4 electrons from the 4 chloride ligands. You have a total of 14. And then there are 2 negative charges here. So you have a total of 16. And this number is correct. I'm saying this neutral ligand method can still be used to count the number of valence electrons correctly. But again, it has just no physical meaning. Why do we treat each chlorine as a neutral radical? It does not make any sense. So now let's look at this donor pair method. In this method, we consider all those ligands as the electron donors. The ligands donate electrons to the transition metal center. They donate electrons in pairs. Now, same example in this tetrachloride platinum with a oxidation number of 2. Each chlorine minus donates a pair of electrons to the transition metal. And we know the charge on this PT is +2 because each chlorine has a -1 charge. Overall, the complex has 2 minus charges. Therefore, you've got to have 2 plus on platinum and -4 charges on these 4 chloride ligands. So in this case, we know this PT has 8 valence electrons, and each chlorine minus donates 2 electrons. In total, we have this 8 plus 4 times 2. We also get this 16 valence electrons. So by using this neutral ligand method, we get 16. By use this donor pair method, we also get 16. And this is indeed a correct number. Indeed, 16 valence electrons surround the transition metal center. So both methods give us the correct number of valence electrons. However, this neutral ligand method does not make any sense, considering this chlorine as a neutral radical. And also, there's an advantage of using donor pair method. When you use donor pair method, you determine the oxidation number of the transition metal. And the oxidation number on the transition metal is a very useful information. So always use the donor pair method. Forget about this neutral ligand method, although it may give you the same number of valence electrons. So again, do use this donor pair method. Each donor donates 2 sigma electrons to the transition metal. If you have a bidentate ligand or tridentate ligand, if they indeed form 2 sigma bonds or 3 sigma bonds with the metal, and then you say, well, each ligand donate 2 pairs or 3 pairs of sigma electrons to the transition metal center.